Is porn addiction a real measurable condition? Or is it just a moral judgment that's been dressed up to look like a diagnosis? To find the real answer, we can't just rely on opinions. We have to look at the brain itself, and the science is starting to reveal some pretty surprising truths.
So, this is the big question, right? For the longest time, all we really had were arguments. But now, neuroscience is actually giving us some real measurable data to work with.
So what are the two main camps? Well, one argument is that, look, this is just a high sex drive meeting unlimited, super easy access. But the other side? They point to brain science and say it follows the exact same blueprint as other behavioral addictions, like gambling.
Okay, so before we can say if compulsive porn use actually fits the bill, we need to understand what addiction is from a scientific point of view. How does it work in the brain, whether we're talking about a substance or a behavior?
It all starts with the brain's reward system. This is our ancient, hardwired circuitry designed to make sure we do the things that help us survive. When you do something essential, like eat a good meal, your brain releases a chemical called dopamine. And that's basically a little signal that says, hey, that was important, remember it, and go do it again.
So how does this survival system get hijacked? Well, neuroscientists have mapped it out, and it happens in a 3-stage cycle. First, you have the binge. That's a massive rush of dopamine. Next comes withdrawal, where the system kind of crashes, creating bad feelings and tolerance. And finally, there's craving. This is when the brain's control center gets weakened, leading to that compulsive hunt for more.
And all this research led to a major shift in how medicine sees things. Back in 2011, the American Society of Addiction Medicine officially updated their definition of addiction. What's so huge about this is that they recognized addiction as a disease of the brain's wiring that can be driven by behaviors, not just substances. So, with that addiction blueprint in mind, how does compulsive internet pornography use actually measure up? Does it end up hijacking the brain in the same kind of way? This is where the evidence gets really compelling. When you put the neurobiology side by side, the parallels are just striking. We're seeing the same brain regions light up, the same flood of dopamine, and the same pattern of cue-triggered cravings. On a really fundamental level, the brain's reaction looks remarkably similar. And we can zoom in even further, like right down to the molecular level. Scientists have actually pinpointed a protein called delta phosB that seems to act like a master switch for addiction. Think of delta phosB as a memory molecule for addiction. While dopamine gives you that short-term rush, this stuff is what creates the long-term changes. It builds up slowly over time and can stay in your system for months, physically rewiring your brain to make it more vulnerable to relapse. So we're not just talking about a fleeting feeling. This is a lasting change that primes the brain for craving. And here's the key link. This protein is triggered by both drugs and intense natural rewards, like sex. Okay, so the theoretical model lines up pretty well, but can we actually see these changes in a human brain? Well, modern imaging technology gives us a direct window into what's going on inside our heads. And brain scans are revealing some very real differences. In people with compulsive use, scientists are seeing physical changes, like less gray matter in a key reward area. They're also finding weaker connections between the part of the brain that says, I want it, and the part that says, hang on, is this a good idea? That's our impulse control center. Seeing changes on a brain scan is one thing, but do they actually translate into measurable changes in how our brains function? That's the next critical question. To test this, researchers used a classic tool called the Stroop test. It's a really simple but powerful way to measure your brain's executive function, which is basically its ability to manage conflicting information and stay focused. So, in one study, they had 2 groups, high-frequency and low-frequency viewers, take this test right after watching pornographic material. The results? Well, they were unmistakable. What this shows us is a measurable, temporary impairment of their executive function, which is a key marker of addiction. After being exposed to the stimulus, their brains just struggled more to stay on task. This isn't just a feeling, it's a quantifiable drop in cognitive performance. So this all leads to a final, really powerful idea. Why is modern digital content so potent anyway? The answer might be found in an evolutionary concept known as the supernormal stimulus. I love this quote from evolutionary psychologist Deirdre Barrett. She points out that while animals usually only encounter these things in lab experiments, we humans have become absolute experts at creating them for ourselves.
So, a supernormal stimulus is just an exaggerated version of a natural trigger. The classic example is a bird that will completely ignore its own pale, small eggs to try and hatch a giant, brightly colored fake one. The fake egg is an artificial stimulus that just pushes all the right evolutionary buttons, only way, way harder. And this is where it all comes together. The endless novelty, the variety, the intensity that's available online can act as a powerful supernormal stimulus for our own reward system. It delivers a level of stimulation that's far beyond what our brains ever evolved to handle. Now, it is really important to remember that this is for educational purposes. If you have personal concerns about your own habits or your health, the best course of action is always to speak with a doctor or a mental health professional.
So this really leaves us with a much bigger question. In a world that's just filled with digital superstimuli, from hyperpalatable food to endless social media notifications, we have to ask ourselves, how is our constant exposure to these modern high-intensity triggers fundamentally reshaping not just our brains, but the very way we behave?